to just work on practice exams, FRQ practice, do's and don'ts on your FRQs, because I have a whole video of that, all kinds of stuff, okay? But we've got some time till we have to start worrying about that, but I thought that you guys would like to hear that, because it kind of makes you feel like, because I know sometimes, maybe not as much in this class, you guys, you should have your notes out. Maybe not as much in this class, but there are days you probably walk out of here like, I don't know what the heck she said, that was another language. So, but look at what your grades have been overall. They have been very good. And so that's why I grade on that square root curve. I do it to match what happens on the AP exam. So think about that. Okay, so we're going into graphing sine and cosine. I'm going to do the notes with you. I'm going to do almost all the homework with you. We're going to be doing a lot of graphs together, so just buckle up. Let's go. Not hard. Just for some of you, a review of what you learned in Algebra 2. You know, I like to skip through some stuff and just focus on what we need. The sine function is a periodic phenomena. Remember 3.1 when we did at the beginning of this unit? We had all those like graphs that repeated themselves, and some of them were kind of tricky, like where they started and where they ended. We had a lot of discussions about that, like it looks like it's like this and whatever, and you had to decide the amplitude and the period and all that stuff. Those were periodic phenomena. Cosine and sine are periodic phenomena. They follow all of those rules, except it's a lot easier. It's very easy to tell where a period starts and ends, okay? But that's why some of the language is going to be familiar to you from last week. But a sine function matches a measure of an angle in standard position with the y-coordinate of a point on the unit circle. So I'm going to skip all the way down here and introduce it to you, explain that with this example. This is your parent function of sine. This is the most basic graph points, and we're going to talk about that, dissect it, and then we'll talk about what happens when we throw some numbers in there that transform the sine graph, okay? So we start with a table of values, and if you notice, these x values are all different thetas from the unit circle, right? There's some from quadrant 1, their quadrantals are all in there, quadrant 2, quadrant 3. They're just angles off of here. Not all of them, just a select few. We always include the quadrantals because those are nice points to graph. Zeros and ones are really easy. And then we have to pick some in between, and that's what we have here, okay? So those are your x values. Your y values are sine of those x values. Sine of pi over 6, sine of pi over 3. So I'm going to go ahead and steal them off the unit circle, off my key, and write them in here. And you guys will do the same thing. So understand, I'm getting these right off the unit circle, the y value at each of these thetas. And you can look at the unit circle and see these. Just get them written real quick. So we're going to answer a few questions about the points we just found, namely, where are the intervals where the graph is increasing? Now remember, that word intervals, and in a second we're going to do decreasing, so increasing and decreasing. Remember what intervals means. It's the x-axis. What part of the x-axis is this or this happening, okay, from this to this? So where are we increasing? Literally, the number is going up, which would make the graph be going up. So if you look at the points here, we go from 0 to 1/2. That's going down. Nope, that's going up. 0, 1/2, whatever that is, up to 1. Okay, so from 0 to pi over 2, and if you put square root of 3 over 2 in your calculator, you would get 0.87. So that's how I know I'm going to start going down there. So I am going up from 0 to pi over 2. Notice I use the x-axis values. Then I start going down, so we'll come back to that with the decreasing. But there is another part of the graph where we start increasing again, and it starts here. From -1 to 0, we're going up. Again, this is -0.87, and so going to the right, these numbers are going to get big. This number is going to get, from -1 to 0 is going to get bigger. So we have 3 pi over 2. Remember the x-axis. We're tempted to grab the y values because that's what we're looking at. But remember, we look at the x-axis. So you'll see this visually in the graph in a second, or you can glance over to the top of the next page. The graph of this is a graph for you. That's where we're increasing. Okay? Where are we decreasing? Well, remember, from 0 to 1, we were going up. And then 1, 0.87, 0.5, 0, all the way to, let me write it first, it's easier. So from pi over 2 to 3 pi over 2, we are decreasing. We're slowly getting smaller and smaller. But remember, we were increasing as we went from here to here. Okay? So we are increasing, then we're decreasing, then we're increasing. It's a wave. Okay? And we'll see it in a second. That's kind of confusing. Don't worry about it too much. It's not something that you'd have to like. Usually we would pull increasing and decreasing off of a graph, which is so much easier. Okay? All right, max and min. Those are points, right? A maximum point. That's an ordered pair. Okay, we got to remember all that little stuff when we put all of our year together and we're doing FRQs and having to remember what interval means, you know, that stuff. Okay, this stuff keeps popping up over and over again. Okay, so can you guys tell what the biggest y value is out of all these? 1, right? 1 is the biggest y value. So that ordered pair is pi over 2 and 1. That's our max. So our min is -1. And you'll see that better on the graph at the top of the next page. But that ordered pair is 3 pi over 2, -1. Now, when we graph, any graph that we've graphed in our entire life, we don't graph every single point and every single point in between those points. Let me give you an example. If you had to graph this parent function, the way you learned it, the way in the beginning was a XY chart. We picked 0, 0, 1, 1, 2, 4, right? And we reflected it. There's your parabola. Well, are those the only points between -2 and 2? Of course not. That's a point. We didn't say anything about it. That's a point. That's a point. It's just a bunch of points, right? We picked numbers that were nice and easy on both sides, okay? So that's what we do here. We're not going to graph pi over 6 1/2. We can, but yuck, right? So we pick easy numbers in here. And our min and max are 2 examples of easy numbers. Do you see some more that are nice and easy in there? All those x-intercepts. Thank you, yes. All those y values that are 0 are x-intercepts. Those are easy to graph. Okay, so those 5 points that I just highlighted are what we're going to start calling our 5 key points of sine, the parent function of sine. So at the top of the next page, you can see the graph of it. We have 0, 0, pi over 2, 1, there's your max, pi 0, 3 pi over 2, -1, there's my min, and then 2 pi 0. What the sine graph is made up of is 3 x-intercepts, a max, and a min. Okay? So 5 key points. Technically, they call them, Elizabeth, you okay? An intercept, a max, an intercept, a min, and an intercept, okay? But when we start moving this graph up and down, we translate it up and down, we don't have intercepts anymore that match up with that. So instead of saying these words, my mantra in most math teachers, I'm not saying this is mine, we say middle, up, middle, down, middle. That's my little mantra for sine. That's the pattern of the graph. Middle, up, middle, down, middle. When we get to Monday at this time, we'll be doing cosine. All the notes are identical except that right there. Every single thing is going to be the same except for that. The pattern of the points. Okay? So middle up, middle down, middle, which is these things in there. Okay? All right. So let's talk about now going outside of the parent function. We throw an A in, we throw a B in. Well, A is our amplitude, okay? And we talked about that in 3.1. A also does all the same things to this graph that A would do to this graph. The minute I throw a 2 in front of there, my graph stretches vertically by a factor of 2. I put a negative in front of it, it's going to flip it, right? So A in every function we work with in our whole world of math stretches, shrinks, and flips over the x-axis. So let's come back to that. The domain of this graph is negative infinity to infinity. Arlen, you need to put your head up and be working. Amplitude is the absolute value of A. We just talked about it. This infinity, negative infinity business means this curve repeats itself forever and ever in both directions. It's the same thing forever. Just keeps on going. That's what that means. Key points, we just talked about those ad nauseum. Right there. The range of the parent function is negative 1 to 1. That's going to change when we stretch and shrink, right? We went up to 1, down to negative 1. Now, period. Everybody pay attention. Period is where there's a little bit of trickiness if you're not careful, but I have a great way for you to know it. The period, it equals, you have to know this little formula, okay? Sometimes you're given B and you need the period. Sometimes you're given the period and you need B. So these two formulas are the same formula, just rearranged. I'm not going to take the time to do it right now, but if you later want me to do it, I will. All I did was multiply both sides by B and solve for the other unknown, okay? So multiply both sides by B, divide by period. What I want you to notice is that 2 pi is in the numerator in both equations. We will use both of these in the homework in a minute, so I will come back. So this is going to be really, really important to understand what we're doing in the homework. But it's super easy, okay? It's just something we have to talk about. All right, let's do our first one that's not a parent function anymore. They're throwing an A in there at us. I'm going to change how this is done. So change this to x, y, and make this the word rule. So what we're doing here is we're starting with our 5 key points. Please make these changes. These are our 5 key points from the bottom of the page before. Okay. Now, what's going to happen to our graph if there's a P that comes out here? So guys, that's a vertical stretch by factor of 2. When you stretch a graph, does that affect the x or does it affect the y of an ordered pair? To your points. If I stretch or shrink something, does it affect x or y? Y. Yes, Imelda, y. Think, vertical. You do something vertically, that's the y value. So watch, our rule is we ain't doing nothing to x, but we're going to stretch our y value by a factor of 2. And we just go through these points and we do that. If you multiply 0 by 2, you still get 0. You multiply 1 by 2, you get 2. You multiply 0 by 2, you get 0, and so on. So our x-intercept stayed the same, but our min and max stretched from parent functions at 1 to 2 and negative 2. So when we go to graph it, we have 0, 0. Here's pi over 2. Pi over 2, 2, and so on. Pi over 0, pi 0, 3 pi over 2, negative 2, and 2 pi 0. And there is one period, one cycle of the graph of sine. Notice it is always 5 points. 1, 2, 3, 4, 5. 5 points, always. Not 4, not 3, not 7, 5. Okay? Let's add another number in. This is really our last example before homework. Stay with me, even though there's more pages. See, this is how the chart should look. The other one was messed up. We're on example 5. So there's the starting points. Those are the parent function starting points. What is going to happen to those points given now we have an A and a B value, okay? Now, we just talked about what 3 does to, like, that's a vertical stretch, right? We already know that 3 is going to affect the Y axis, the Y value, okay? What is the negative going to do? Our decisions basically here are which letter, X or Y, do the numbers in here affect? Which ones are going to change? So again, 3 affects the Y, right? What about that negative? If I have a point at 2, 1, and I flip it over the x-axis, what changed? The Y. So when you get stuck and you can't remember, like, think about how you could figure it out, right? You could just kind of think about a graph. What changes when so it's the Y. So far, let's leave X alone for a second. For Y, we're going to be multiplying our Y values by -3, right? That takes care of the negative and the 3. So moral of the story is anything that comes right after the equal sign before the word sign goes with Y, okay? The number inside here, B affects the period. Listen to me, make this connection. B affects the period. Period is how much of the x-axis you use. Are you using 2 pi? Are you using pi? Are you using 3 pi? Are you using half a pi? How much of the x-axis? That's horizontal. What letter has to do with horizontal movement? X. So anything inside hanging out with X affects X. One more thing to make things a little confusing. Instead of 2, it's 1/2. We learned it many times. It's the one that you haven't seen as much in Algebra 2, so this year it was kind of the only new transformation. Anything that's in the parentheses with X, you have to flip it. And we had it in our notes, and I have it on my list of things to do to pull it out again so I can show it to you guys on Monday, because everyone, when I say that, goes what Ty just did, goes, what? Okay, so, but anyway, we're going to go through these and do this real quick. If I multiply 0 by 1/2 and 0 by -3, I'm still 0, 0. Okay, multiplying 0 by something doesn't change it. Pi over 2 times 1/2 is pi over 4. So pi over 4, and then 1 times 1/2, 1 times -3 is -3. Next one, pi times 1/2. Let's multiply straight across, right? That's just pi over 2. Multiply 0 by anything, and get 0. Multiply 3 pi over 2 by 1/2. Multiply straight across. That's 3 pi over 4. -1 times -3, 3. And 2 pi times 1/2. The 2's cancel. No, what did I do wrong? 2 pi times 1/2. I wonder if my key is wrong. Oh, I'm on the wrong page. It is fine. It's just fine. I was on the wrong page. Sorry. I'm like, wait, did I do that wrong? Okay, and then 0 times anything is 0. Right? So you can see we're going from 0 to pi on the x-axis. All 5 of our points are going to be between 0 and pi. So 0, 0, pi over 4, -3. We're going down first. We'll talk about why. This one up to 3, and then here. So this one is a middle, down, middle, up, middle. Why did we go down instead of up like I told you we would? It's a flip. Okay, so if that negative weren't there, it would have been middle, up, middle, down, middle. But because it was a flip, it went middle, down, middle, up, middle. 5 points to make the graph. Okay? Now, we're not going to do this last one. We're going to do the homework, but I just want to talk about this one. I just want to talk about what the rule would be. So, XY starting points, we know that that 2 is going to affect the Y. Anybody remember what this would be? We're going to see it in the homework. Up 2, yeah. Is that X or Y? Going up, is that X or Y? Y. So if you were going to do this one, we're not going to, you would multiply all your Y values by the 2 in front and then add 2. That's how you would get your points. Multiply all the Y values by 2 and add 2. There was no number in the parentheses, so nothing affecting the X. Okay? All right. Homework. C 15. I'm going to omit number 8. The x-axis is a little tricky, and we'll have a lot more time on Monday to deal with x-axis stuff. But this homework really doesn't match the notes very well, so I'm going to do a lot with you, and I think this is really going to help you guys understand these. Yes. I'm going to start, though. You definitely want to hurry back. All right. So, here we go. What we're going to do is find the amplitude and the period, and then write the equation for it. That's all we're doing. It says a lot of other things. Okay? So we're going to find the amplitude and the period of each of these. All right. And then we're going to write the equation. So this looks funny. Does this look like yours? Yeah. The one I did earlier started lower. That's why I was wondering. I just want to make sure I'm on the right page. Okay. To write the equation, so this is how I'm going to do it. To write the equation, I need to know what A is, and I need to know what B is, right? To plug into this function, A sine X. I didn't mean to put it in parentheses, but it's not bad to put it in parentheses. Oh, B. God. Guys, my room looking like this is making me crazy. I'm telling you, I can't handle the chaos over here anymore. It makes me, like, crazy. Crazier. Okay, so A, amplitude is the easiest. Okay, if it's the same height at the top as the bottom, that's an easy way of finding the amplitude. If it goes up and down below the x-axis the same amount, that's your amplitude. There is a formula we learned for amplitude that we could apply here, but you don't have to. But we have to on a different problem, so I won't waste your time right now. That's a quick way of doing it. B comes from our period. So let's figure out what the period is. All we do is start at 0 and count 5 points by going middle, up, middle, down, middle. Middle, up, middle, down, middle. That is one period. How far out did we go? 2 pi. That's your period. It's that simple. But be careful. Period and B are two different things. Okay? Remember those formulas I told you I would come back to? What do we need? We need B. So we just do 2 pi divided by the period. 2 pi is what the parent function period is. We're changing it by whatever B is. Well, guess what? In this one, B is just 1. This is the exact amount of the x-axis that the parent function uses. That means we don't have a B value, or we just call it 1. Final answer would be, right? You can imagine a 1 in front of that x. All right, let's do another one. I know to write the equation, I need A and I need B. Again, amplitude 2, negative 2 gives me a 2. Okay? I don't know B just by looking. So I need to use this knowledge, the period. Count 5 points. 1, 2, 3, 4, 5. Middle, up, middle, down, middle. Those specific 5 points, I should say. Okay? How far did we go out? Pi. That's how much of the x-axis we use, from 0 to pi. That chunk, that's your period. Now to find B, 2 pi is always in the numerator, you divide by your period. Easy peasy. Arlen, you have to stay awake. So then just plug the A and B in. Okay, next one. A, B. Amplitude, still nice and easy, 2 to negative 2. We don't know B until we find our period. Middle, wait a second, we're going down. Middle, down, middle, up, middle. What does that mean for my equation? A is negative, right, Bishop? We flipped. You can see it in the graph. The normal one is middle, up, middle, down, middle. So when we flipped it, it changed our A value to have a negative in front. All right, the period would be 4 pi, right? 4 pi. To find B, we divide 2 pi by our period. Always remember 2 pi's on top. Yes? Middle, up, middle, down, middle. Middle, up, middle, down, middle. Middle, wait, what happened? Our mins and maxes switched places, okay? Middle down is a flip. So y equals negative 2 sine of 1 half x. Where I'm getting what? A is the amplitude. We go up to 2, down to 2. Same thing on number 1 and number 2. But number 4, things are changing. They gave us a challenging one. This is 2. This is negative 4. So we can't just grab that number. Back in section 1, we learned this formula. I'm going to try and find some space here. Amplitude equals 1/2 the max minus the min. You can simplify that. Subtract the two numbers, make it positive, and divide by 2. However you want to do it. But when you do the absolute value of max minus min, and then divide it by 2 is what that means. This is 6. Half of 6 is 3. Our amplitude is 3. You guys remember that? We did it back in 3.1. And it doesn't matter what order. You can subtract your max from your min or your min from your max. Just make it positive because it's distance and divide it by 2. That's your amplitude. Okay? But stay with me for when we write the equation. B, we don't know until we find our period. So starting at 0, middle, and I'll just see how we're going down. This is another flip. Middle, down, middle, up, middle. 1, 2, 3, 4, 5. What are we at right there? Pi? I can't see. So period is pi. To find B, it's 2 pi, always on top, divide. Wait, what? It is. It is. Wait for it. You're right. I'm so glad you see that, though. So if you can't hear what Ty is saying up here, he said it's translated down. I mean, I'm impressed by the language too, Ty. Translated down one. That's exactly true. If only these were all shifted up 1, we would be at 3 and negative 3, right? But really we're at 2, negative 4. So we actually have that k value at the end of minus 1. So watch. Again, negative here because we're going down. So y equals negative 3 sine, parentheses of 2x, then we write minus 1. So if your max and your min aren't at the same number, that means your graph moved up or down a certain amount. Okay? That's tricky. We'll see it again on Monday. Remember, Monday is like doing the same lesson over again, so any holes in your knowledge hopefully will be answered. Because now we're going to switch to a different type of problem. They're giving us the period and the amplitude. What we're going to do is sketch one cycle and write the equation. I like graphing it first. Graphing, I think, is even easier than the other. So we have an amplitude of 3, so we're going to go up 3 and down 3, and we're going to go out to 2 pi and make 5 points. It's always 5 points. So my last point has to be here. So I start here, middle. And remember, another way of looking at it is you're going to have 3 x-intercepts, right? Up, up, up. And we're going to have a max and we're going to have a min. So you could actually put your x-intercepts on there to kind of break up your x-axis, and then put your max and your min. I can't see. Now, are there variations on this where you could do kind of like what we did on the last one and do some upping and downing? Of course you could. We're making life easy. So to write the equation, don't forget, we need A, we need B. We know A is 3. We need B. B is 2 pi divided by the period. B is 1, which should make sense. Parent function goes out to 1. Y equals 3 sine x. Okay? Period of pi. All 5 points have to go out to here. We'll have an x-intercept at the first and at the last, and somewhere in the middle, not somewhere, exactly in the middle. You're going to learn as we go through this next few sections, the hardest part of all these is making your x-axis perfect. X-axis is the challenge. But in the beginning, they're not so bad. So you have 3 x-intercepts. Positive 2 will go up to 2 in the middle of those 2, and down to 2 in the middle of those 2. Period goes out to pi. That's how long, much of the x-axis we use. A is 2. B is 2 pi divided by your period, which is 2. One more of these. See you writing, Jordan. Are you good on that one? Okay. And remember, we're not going to do 8 today. I'm going to do 2 more with you, I think, and then I'll leave you alone. Plus the bell might ring, so, well, we have a little bit of time. Okay, we go out to 4 pi. So we have to make this x-axis even. You can't just draw it however you want. I know we want to. So let's talk about how long it's going to be. So we're going to have so middle up, middle down, middle. So our ends are middles, meaning x-intercepts. And then we have one in the middle. What's in the middle of 0 and 4 pi? What's in the middle of those two? 2 pi, right? There's our other x-intercept. Evenly placed, 0, 2, 4. And then in the middle of 0 and 2, we would have our max at 2. And in the middle of these two, which would be 3 pi, we would have our min. Sorry, it might be off a little. Let's see. Okay? So the graphs usually are pretty simple. Middle up, middle down, middle. 5 points spread evenly from 0 to 4 pi. Okay? Oops. A is 2. B is 2 pi divided by our period. Pi's cancel. 2/4 equals 1/2. Are you lost, Amanda? Did I lose you? Do you have a question for me, hon? So, period tells me how long this is going to be. I'm going to try this. So I know the period is 4 pi. That tells me exactly how much of the x-axis I'm going to use. I know my graph, also I know, that has 3 x-intercepts. Middle up, middle down, middle. And they're equally spaced. So at the first and at the last one, I have an x-intercept. And then dead center between them. What's in the middle of 0 and 4 pi? Half of 4 pi would be 2 pi. Then in between 0 and 2 pi would be 1 pi. So that's just how I'm breaking up the x-axis. Okay? It'll click. It'll click. All right, last type of problem. Don't worry about the rule. Cool. Amplitude, 2. Now guys, we need the period. What do we have? We have B, right? B is 1. We want the period. It's the same formula. If I want the period, I do always 2 pi in my numerator divided by B. Before we needed B, now we need the period. Same formula, 2 pi divided by what we have gives you what we don't have. Okay? So that means, and why do we even need to know the period? Because we need to know what I was just saying to Imelda, how far out to go. Here's my tip for you when you have to break up the x-axis. Break it up in even numbers. Like I like to go since I have so much room, I'm going to go out like 4. 1, 2, 3, 4. 1, 2, 3, 4. What that does is gives me, this would be 2 pi, half of 2 pi would be pi. And that's plenty for labeling. Okay, those are my x-intercepts. Then I need a max and a min halfway. And by going out 4, there's a nice easy line right in the middle. Okay, that'll go up to 2 and down to 2. It's going to take some practice to get good at the x-axis. But stay tuned. See how I do it. I give lots of tips. Okay, that's not hard. We just have to get comfortable with it. That's it. That's all we're doing for this, right? Yeah. Let me do one more with you. Amplitude is 3 with a flip, right? So this one's going to go middle down. We'll still have our 3 middles. That's the part that really guides us. We don't know our period, but we do know B. B is 1/2. B is 1/2. We need the period. Okay, fine. Period equals 2 pi, always 2 pi in the numerator, divided by 1/2. Dividing by fractions, we keep, change, flip. I'm going to break up my x-axis the same exact way. 1, 2, 3, 4, 1, 2, 3, 4. So I'm going out to 4 pi. 0 to 4 pi. What's in the middle of 4 pi? 2 pi. Even though my graph's going to look almost identical to this one, by labeling it, I'm saying what the length. I mean, it's not drawn really to scale, right? The labeling is what matters. And because it's a flip, I'm going to go down to -3 first, and then up to -3. There's my -4 flip. 5 points from 0 to 4 pi stays even. Okay, I left you 2 to do. I know that was a heavy-duty day for a Friday. Not much I can do about it, but that makes Monday a little bit easier. Think of it that way. Hallelujah.